Today we are talking to Bradford. Hi, Bradford.
Hello, how are you?
I'm well. Bradford is a software engineer working at Google since October 2010 and have been working on the Closure team since April 2016. So today we are going to talk about Google Closure. So what is Google Closure?
So Google Closure is two pieces. It's all about JavaScript. There's a JavaScript library of sort of core JavaScript functionality, and then there's a compiler, which is all about compressing your JavaScript code down to the smallest possible size for loading to the browser, and about checking for programming errors.
Mhm. And today we are going to focus the discussion on the Google Closure compiler.
Right.
All right. Okay. So how does the Google Closure compiler work?
All right. So the idea is that if you want to use Google Closure Compiler, you write your JavaScript in a way that gives the compiler extra information. Typically, you can use JavaScript that hasn't been written this way, but the compiler does a much better job if you do things like when you write a function, you add extra annotation comments to say, oh, this function expects a number and a string, and it's going to return a string or null, or something along those lines. When you define classes in your JavaScript, you can annotate them to indicate exactly what the different properties on those classes are supposed to be. And this allows the compiler to do a much better job of checking for errors, and also of compressing the code than it could do with just normal JavaScript that doesn't have these annotations, because it can reason about the objects that you have. It can say, oh, well, I see property foo only exists on this one class, so anytime I see a foo in here, it must be because this is an object of that class, and I can rename all of those to be the same when I compress the code to make it much smaller.
Maybe it would be actually good to just talk about on the high level the architecture of Google Closure.
Okay. On the high level, the compiler works like this. It reads in the JavaScript that you're given. It also reads in a set of externs files, which are also JavaScript. I'll get to those in a second. And it converts all of those into an abstract syntax tree, which is just a binary representation of what was in the code. And then it works by reading across that abstract syntax tree many, many times, and gathering information about it, and then making modifications to it. So in the simplest way of thinking about it, you can just say it reads in all of your code into this abstract syntax tree, then it reads through it to learn everything it can about your code and check for any programming errors that it might be able to discover. And then it repeatedly goes through making improvements to the code, mostly focused on code size, finding things that are not used and removing them, renaming things, reorganizing the code in ways that are more compact, renaming all of your variables and properties so that they're much, much smaller. And so as a result, we can get output that is sometimes a quarter the size of the input, significant savings.
So when you say it does multiple reads of the code, how does it know how many times should it read the code?
Well, the compiler is divided into multiple passes that have different responsibilities. For example, there's a set of about three passes that are all about type checking. And so their job, like the first one, reads through and looks at all your type annotations, and then figures out what the different types of objects are, and then it adds annotations to the AST to say, oh, this is this type and this is this other type. Then one reads through and does inference, like, well, because this was assigned here, this must be this type, and so it goes a little further. Then there's passes that so to some extent we do passes to get certain jobs done. There's one that goes through and gathers all information about all the getters and setters defined in your code, and so on. Then when we get to the optimization stage, where we're going to actually start trying to change the code, there's two different ways, two different kinds. Again, there are some things that just do something once. They go through and they rename all of your properties in some particular way, for example. But there are others that work iteratively, because, for example, there's a pass whose job it is, there's a pass called the peephole pass, and it basically looks at little tiny sections of code and just realizes, oh, this if could be rewritten as a binary, like A or B, and that would be a lot smaller. So I'll rewrite this little bit like that. And then there's another pass that's responsible for discovering, oh, this function is only used once, so I can just inline it there. or it's maybe used a couple times,
Mhm.
but it's so small that really I would get a size benefit if I just inlined this function everywhere that it's used. Um, and those are done in an iterative fashion because a lot of times when one pass does this work, and then you redo an earlier one, it'll say, oh, well, now that that was inlined, I now can see that I can change this if to an or in order to make things smaller. We can't do everything at once. That would just be too confusing. So we have specific like optimizations and we just run them in a loop until we reach a stable state where, okay, nothing else is changing. We've found all the things that we could to make better. So we'll stop.
Is there any way to configure number of passes that we run through, or how does that work? Or this is like a specific set that you just figured out, well, this is the best way to do it, and you just do it
Ah,
in the
Well,
compiler?
there's a couple things. By default, right now, the compiler actually uses a heuristic to say it doesn't actually necessarily go all the way to a steady state. It may just say, oh, well, not enough has changed to be worth stopping. There is an option. I'm not sure if it's exposed for the open source version of the compiler, but there is an option to just say never do more than X loops. And actually, we're thinking that's a better way to go in the end. We'd like to expose that and have people start using that instead of the heuristic method because you would get more reliable output. You would know, because otherwise, with the heuristic method, if you make some change to your code, then suddenly you might have a surprising change in code size because the heuristic happens to do something different. But if you know that you always run exactly this many passes, then you get a more consistent output size. And it's just a little bit. It's easier to control the how long it takes the compiler to run that way as well, because well, it with the heuristic, the compiler might suddenly take a lot longer because you did something that made it need to do more iterations. But if you need a reliable, like it's always going to be done in a certain period of time, then you can set the number of loops. It's sort of like with the C++ compiler. I think you can set optimization levels, like it optimizes more or less. It'd be kind of like that.
Right. Yeah, I mean, in Clojure script community, we love we love Google Clojure, and we use it a lot to generate our JavaScript code. So we write Clojure
Mm-hmm.
script code, which generates the Google Clojure compatible code. So there are certain restrictions on Google Clojure compatible code. So maybe we can talk
Oh,
about this
certainly.
a little.
On the Clojure compiler like wiki page, there's a compiler assumptions page that lists at least some of them. But some of the assumptions we make is that we're going to assume that that just accessing a property on an object is never going to cause something to throw. We assume that that's not going to throw an exception just because you access something on a property on a method. We tend to, at the moment, we assume that all your getters and sitters are side effect free, but I'm working on changing that so that we want to assume that property accesses when you do a dot b, that you're always going to access b property b as a dot b and never a square brackets some variable name that happens to have b in it. Because if you do it that way, it's hidden from
Right.
the compiler, and then we can't safely reason about things. So a good way to get the compiler to break your code is to sometimes refer to a property with a dot b and sometimes refer to it as a square brackets and then some expression that evaluates to b, because
Mhm.
that makes it really hard for
Right.
the compiler to figure out what is going on in your code.
Right. So when the Google Closure compiler goes through the code, it looks for like the objects and then the properties. And if we use them in a different like dynamic way that we, as you say, with the brackets, it cannot optimize the code because it will also rename the property name. So whenever we use something dynamic, this will
Right,
break the
because
code.
it's going to try and rename your properties to make things smaller, and if you're doing some things where it can't see that what the name is, then that is a problem.
Right. What are the other restrictions? What should people
Uh,
not use?
a lot of them are things that at least to us seem like sort of obvious things that are bad. Don't go and like monkey patch stuff in the Java library. Don't go and change the way the core JavaScript features work by adding extra properties to the array class or changing the way something works in that sort of thing will definitely break us because it's like we assume, for example, that the toString method on an object never has side effects, but if you write one that does, then that's going to be a problem.
So don't modify the prototype.
Yeah, don't modify the prototypes of like things that are built into the language. In general, actually, we tend to assume that things are fairly static. If the though we back off when we can. But suppose you wrote a class where like the class has a method on it, and you at some point in the future you change that method to do something completely different. I mean, by actually like reassigning it, we would notice that, and we would try to avoid some of our optimizations. But it's still not a great idea. Things will work a lot better if you're basically writing your class once and it's like fixed. This is the way it works, and then the compiler can reason things about things better and do a better job.
So Google Closure is a whole program optimizer. So it needs to see all of your code whenever, like when you shovel all of the JavaScript code inside, it should see everything. But when we use like any kind of NPM package or anything, it cannot see everything. So what are the ways we can deal with this?
That's where we get back to the externs files that I mentioned earlier. Externs files are JavaScript with the type annotations in them, like what I described, but they don't define any actual functionality. They exist sort of like C or C++ header files. They're there so the compiler can read them and know, okay, there is an object class, and object has a toString method on it, and it has a value of method on it. And so that all these things that are core to the language, we already have externs files available for. And usually you don't even have to tell the compiler to read those. It automatically includes that in your input. Um, but if you're using something like jQuery or Angular, then you might need to explicitly give the compiler some extra externs files to say, oh, and by the way, I'm going to use these things. So the compiler can know, oh, when you refer to a $, you mean the jQuery object. So I'm going to know that that's what you're doing, and I won't try to rename that. And any properties that are defined in that externs file, like special names of methods and things that jQuery uses, it will not rename any of those because it'll say, oh, well, those come from outside of what I can see, so they're not safe to rename. So I will leave them alone.
All right, so what's the story when it comes to ECMAScript 2016, 17, 18, and the future?
We are definitely trying to stay on top of the ECMAScript language specification as they make changes to it. We're regularly checking in and monitoring like what the status of all the different proposals are. For a while, we fell behind. When before I joined the team was when ES6 came out. And the way we elected to support ES6, which had a whole lot of new features, including an actual class thing that you could define in the language instead of the sort of ad hoc way it worked before. And then like destructuring and all kinds of new features were added all at once. So the way we elected to do that, as I described before, that the compiler works by creating this abstract syntax tree and then just doing repeated passes over it, learning things about it and changing it. What we did was we stuck something at the beginning of this process that would translate the new features into an older form that would still work. That's actually a core part of the compiler I hadn't talked about before, but one of the features of the compiler is that you can give it code that's written with the latest version of the language and say, yes, but I want you to generate output that will work on a browser that only knows about ES5. And so the compiler would then run what we call a transpilation pass. Its job is to go and find a specific feature that's too new for your output level, and it will transform the AST so it's not using that feature anymore, but it has equivalent behavior. So we already had this because it had been around for a while. But when we had to support ES6, what we did was we basically just put a bunch of these translation passes early in the process so that it would transpile away all of that ES6 fancy stuff so that the rest of the compiler could just work on the old ES5 features as they always had.
Right.
That had the great advantage of us letting us support it relatively quickly, but it meant that we couldn't actually output code that used the new features because we had to transpile them away to do our work. And it was quite a fairly long process, which we just finished up this past winter, to get all parts of the compiler up to date so that they all understand actually features all the way up through ES 2019. We've finally caught up all the way to ES 2019, so we can actually both read and write ES 2019 code, all the features that are in there. Well, with a couple of caveats, like certain features that we just can't. There's some things you can't transpile. There's something called proxies where you can create an object that acts as a proxy for other objects, and there's just no way, if you're running on a browser that doesn't have that feature, to write JavaScript that does what that feature does. It's you can't do that. So that's the one limitation. It's like we can't transpile everything. But those features that we can, we definitely transpile so that you can write code to the newest level and it'll work on all the browsers out there.
I mean, with every changes, I believe, to any kind of software system, there's always some things that you depreciate along the way. I'm just trying to ask you, are there any tips for ClojureScript compiler maintainers that you maybe are moving away with all of the changes that you did in Google Closure that we should not be using any longer?
One of the most important ones really is a change to the way we allow you to break up your code. There was a previously feature, and it's still there, called goog.provide. It was a library method that you call. You say goog.provide, and then you give the function a string that basically has a dotted path, a.b.c.d in it. And what that does is say this file is going to define this a.b.c.d. It's a promise that that's what's going to happen in this file. And then in another file, you would say goog.require a.b.c.d, which is a assertion that this file needs that thing defined in the other file. And that allows the compiler to make sure that you have all of the scripts that you need and to put the scripts in the right order so that things will be available when they're needed. However, we're deprecating that, because it was still all about doing things at a global level. You were still defining a global name, basically. And that we realized was not great. We still had the problem with that form where when you wrote your script, it was still true that if you said var foo, you're declaring a global variable that now any script that's in your compilation will be able to see, and that's a problem. It wasn't the only way to avoid that was we had another thing called goog.scope that was just a fancy way of wrapping an iffy immediately
Hmm.
invoked function expression around it, around your code, so that it would all the variables you create would not become global. So we decided we should do that better. So we invented goog.module, where you're actually declaring something to be a module. And that's what should be used in the future. We still support goog.provide. And there's still lots of code at Google that hasn't been updated yet, but we expect that to change in the next year or two, and for those to all be gone. We don't have a timeline for when it's going to disappear, but it's definitely not the best way to write things anymore. And you should use goog.module, or we now have support for ES modules, for ECMAScript modules. So you can also use the newer ECMAScript 6 module syntax to declare modules.
Okay, so this is Google.provide. This is one. Is there anything else that would be worth to mention here?
Thinking in terms of what ClojureScript does, because you guys are generating JavaScript code to go into the compiler ultimately.
Yeah.
Um,
Yeah.
one of the new features in JavaScript as of like 2017 are the async functions, and then in 2018 we got the async, basically async iteration, so that you could actually iterate over things that happened asynchronously. Um, and
Hmm.
using those is a very good idea for the compiler,
Okay.
even if in the end you're telling the compiler to compile it, to transpile it all away. If you use those features instead of trying to use promises or callbacks or something like that, the compiler can understand your code way better and do a much better job of catching errors. What you might not care about that because ClojureScript probably handles that part, but also a much better job of optimizing. So that's something to bear in mind for anyone who's like working on figuring out how to translate your ClojureScript into JavaScript. If you use the async functions and async iteration, the compiler is going to do a better job for you. So it'd be a good idea to use those.
Hmm. Right. I mean, in ClojureScript, we use something which is called core async, which is like a library that we normally use for any async stuff. But I'm sure people listening who work on Google Closure or ClojureScript compiler maybe take this input and then maybe they will improve something in ClojureScript compiler. We went through a lot of stuff so far without really talking how is actually Google Closure compiler used at Google. So what kind of products are you building with Google Closure compiler?
Well, the answer is sort of everything that uses JavaScript. The compiler does a really good job of compressing code, and we have because Google engineers often move from project to project. We try very hard to have consistent style to any language, any programming language at Google. So it's basically sort of codified here that like the way you write JavaScript at Google is you write it with the closure annotations in it. And so all the projects at Google pretty much they all use Clojure compiler. So
Okay, so all of the front-facing
yes,
projects
everything.
like Gmail.
Yes, but also internal stuff. We have a lot of internal code, and they all use it too. Because if they didn't, it'd be a problem for engineers trying to move from one project to another. Because it's like, oh, I suddenly have to do things differently than I did before.
Right. So all of the products that we probably love and use every day, like the Gmail, the Google Docs, and stuff like this. So I think it's worth to maybe mention that like you're very committed to the Google Closure compiler because sometimes in our community we sometimes hear some rumblings. Oh, Google Closure is going away. Maybe Google is moving to TypeScript or something like this, and we sometimes hear stuff like that. I don't know
Mhm.
where is it initiated, but sometimes someone just posted on Reddit or something, and then everybody's like, "What are we going to do now?"
Well, you don't have to worry about Clojure compiler going away. We simply couldn't do that. We have to have it. It. I'm sure that over the next few years, it'll change in form to some extent. Uh, but it has to be there. We need it in the end. Like as long as the browsers need JavaScript as the input, we're going to have Clojure compiler to generate it. So we would love to do things where we had support for maybe writing things differently because our core what we see as our core value is the really efficient optimization of the JavaScript code. Without which, basically, Google Docs would be unusable and Gmail would never have the features that it has. Because if all of that stuff was just compiled with the sort of standard simple optimizations that are tend to be widely available if you're not using Clojure compiler, the code would be too bloated to run. But we would like to we want to add more flexibility. Um, there's already and we've already thrown over the wall some things to help TypeScript work with Clojure compiler. For example, like there's a thing called tcl and Klutz. They're a pair of things that will allow you to write TypeScript that will then you can have from your TypeScript you can generate Clojure compiler compatible code, and so that you can do that. So we're what I'm saying is that like we're constantly trying to improve and make it easier to use the compiler, and that's one of the ways we do it. But the compiler is definitely not going away because we have to have it.
Right, right. Yeah, I mean, as I mentioned, we love Google Closure. I mean, it's an open source project. So maybe what's the future for the open source Google Closure? Do you have any plans to improve some parts, or what's the story
Well,
here?
our future plans are very much in flux. One is certainly we're keeping up with the ECMAScript standard. We have to keep up with that standard. And I recently wrote a document for us to this is what our requirements are of how quickly we need to be on top of things, that sort of thing. So that's important to us. And the second is that we want to make the compiler easier to consume and use by people outside. And that will probably involve changes to the compiler to make it easier to just throw any old JavaScript at it and it do more useful things. It will most likely also include more pieces of how the compiler can work with you to create code splitting and to build applications. Clojure compiler is a piece of a whole suite of tools, really, that they're all designed around trying to make it possible to build big applications. It's only a piece, and we recognize that, and we want more pieces to be available outside to the outside world, both because we're nice like that, but also because if the stuff is open source, we recognize that that means more people are using it, more people are fixing it, and we benefit in the end. Our engineers will be happier because they can do things the same way inside Google as you would do outside Google. Um, and the whole world just basically benefits if all of these things get easier to do. So that's that we're very committed to that ideal.
Yeah, absolutely. I think it's, I mean, you share really a lot with Google Closure, and if you want to share more, I think we will be more than happy to take it, you know.
Mm-hmm.
So once again, we love the work you're doing. Just pass all of our gratitude to your team, and we hope to, continuously use Google Closure. So thank you once again for being on the show and giving us all the knowledge around it.
Well, thank you for having me on the show. I enjoyed talking to you about Closure Compiler.
If you find this podcast valuable, there are many ways you can support it. You can review it on iTunes or any other platform you're listening to. You can share it on social media with your friends. You can blog about it, discuss it on your own podcast, and you can support it directly by buying my video courses and learning ClojureScript and Clojure at my website, jacekschae.com. That's jacekschae.com. Thank you for your support of this show.